What's going on, guys? In this video we are going to see how to convert a number from octal to decimal, and also we are going to see how to convert a number from octal to binary. Okay, now let's look at octal to decimal first. Octal to decimal. Octal to decimal. Okay, now we know that when we have a decimal, the maximum number we can have is 9, right? It goes from 0 to 9. When we have binary, the base is 2 for binary, that goes from 0 to 1. So you can see, like, if it decimal base is 10, so we have to have 1 less than that, so we have 9. And if it's binary, the base is 2, we have to have 1 less than that, has to be maximum. So for octal, the base is 8, so it has to be 1 less than that, so we have to have maximum number 7. For example, let's say if we have a question like this, 296 and the base is 8, if they ask to convert from octal to decimal, is this correct? This is wrong, because we cannot have 9 in the octal, right? So this question is wrong. So what we can do is, like, for example, if we have something like this, if we have 1 instead of this 9, then this is correct, because we have every number that is less than 8. So this is correct. Now let's see how we can convert this one into octal to decimal. Now in order to convert this one, the similar approach we do for decimal and binary, like this is the power 0, like if it's octal, this is 8 power 0, right? 8 power 0 is what? That's 1. And this is 8 power 1, that's equal to 8. And this is 8 power 2, that's equal to 64. Now what we have to do is, we just have to multiply, like 8 power 0, that is 1. So 1 in the 1th place we have 6, 1 times 6, plus in the 8th place we have 1, so 8 times 1, plus in the 64th place we have 2, so this is going to be 64 times 2. And 1 times 6 is 6, 8 times 1 is equal to 8, 64 times 2, that's going to give us 128. So 128 plus 8, that's going to be 136. 136 plus 6, that's going to give us 142. So 142 is going to be the conversion from octal to decimal. So the decimal number is going to be 142. Okay, so this is one of the example. Now let's look at another example with the decimal point. Let's say we have a number that is 7.254. So we know that this is 8 power 0, because this is the first number, and we know that if it's going from right to left, we have to increase the power, but if it's go from right to, like, after decimal point, we have to decrease the power. Like this is going to become 8 power minus 1, so this is going to be 8 power minus 1, that is 1 over 8, and this is going to become 8 power minus 2, that's going to be 1 over 8 square. 8 square is 64, so this is 1 over 64. And this is going to become 8 power minus 3. 8 power minus 3 is 1 over 8 cube, that's 1 over 512. Okay, so this is what we are out right now. Now let's go ahead and convert. Let's use a different color. So let's go ahead and add the numbers. So first we have 8 power 0, that's equal to, this is equal to 1. So 1 times 7 plus, this is 1 over 8, there we have 2, so 1 over 8 times 2, plus 1 over 64 times 5, plus 1 over 512 times 4. Okay, so this is going to be 7 plus 2 over 8, that's going to be 1 over 4. And then this is going to be 5 over 64, and 4 over 512, let's leave it as 4 over 512. And if you plug all this in calculator, you are going to get 7.3333359,375. So this is going to be, this is base 8, and this is going to be the conversion from octal to decimal. This is decimal, base 10. Okay, now this is from octal to decimal. Now let's look at an example where we convert from octal to binary. For example, let's say we have a question that's asking, to convert 216 base 8 to base 2. How can we convert this one? Right, so it's like the easiest way is to first convert this one into base 10. So first convert this one into base 10, then we convert that one into base 2. So we already did that one, we used the same number. If we convert this one into base 10, that's gonna be 142. We saw how did we do that, right? We take the positions 8 power 0, 8 power 1, 8 power 2 and multiply the numbers in that position, and that's how we got base 10. Now after we get base 10, we have to divide this base 10 until we get 0. Now let's go ahead and do that. Let's use a different color. So here we have 142. We divide this one by 2, and if we divide this by 2, that's going to give us 71, remainder is 0. And 71 divided by 2, that's going to give us 35, remainder is 1. 35 divided by 2, that's going to give us 17, remainder is 1. And then 17 divided by 2, that's going to give us 8, remainder is 1. 8 divided by 2, that's going to give us 4, remainder is 0. Then 4 divided by 2, that's going to give us 2, remainder is 0. Then 2 divided by 2, that's going to give us 1, remainder is 0. Then 1 divided by 2, that's going to give us 0, and the remainder is going to be 1. So finally we end up with this one. We have to go from bottom to top for binary. So 1 0 1 0 0 0 1 1 1 0. That's going to be the conversion from octal to binary, right? Octal to binary. First we convert from octal to decimal, then decimal to binary. So the conversion of this number from octal to binary is going to be this one. Okay, and we can also write it here, right here. And that's how we do that. I hope this helps. Thanks for watching.